one person is going to be designated the leader, and it's going to rotate every time. And then we'll have one team that will only have two on. But we'll rotate it too. And basically the way we rotate is we just move one person up after every lap. That makes sense? So the guy that was on this team at the top, they would rotate into the bottom team, and then we rotate that. And who's ever at the top of the list will be the leader. So everybody's going to have a chance at being the leader of the team, and everybody's going to have a chance of being a technician. So the lab, first lab we'll do tonight when we get into lab is we're going to do our function chart. So what are you going to do? First of all, we're going to break the line apart. And we're going to put a whiteboard between each station when we get them spread out, so we'll have to spread them out. We're going to have to, we got plenty of extension cords where we can run power to the outlets on the wall. We have the flexible hose pneumatics, so you can hook up the pneumatics for your section. And then you're going to develop these function diagrams. So what's our first step? Once we get that break apart, we're gonna do what? We're gonna put it on single step. Everybody knows how to do that. You just put it on manual, and you're gonna go through the steps, right? I'll give you a picture since the Amatro line does not label all the actuators and everything like the Festo line does. I'll give you these pictures that show you what, like B1, B2, B3, and A1, 1A1, and stuff like that you'll be able to look at. And then you'll write down the steps until it does what? Until it recycles. Then you'll come back once you get your steps. So you need to leave yourself enough space between them, right? And then you'll come back and you'll just, well, in this class, we're not going to worry about putting it over on the left-hand side. You can if you want to, but we can just put lines between the steps, and then we'll put the cross in there, and we'll put what's required to move to the next step, right? Everybody understand that? So everybody okay on the function chart? And then we'll give you a certain amount of time to do that. You may get through, you may not get through. But what happened is then we'll go around to each group. We'll start on the group on the left, and we'll move over, and we'll let the leader and the team explain how they came up with what the step chart is and that kind of stuff. So everybody will have to make presentations, and then we'll do the step charts. I think we'll rotate teams on that one too. Then what we'll do is we'll do the step charts, which is another method of setting up something that makes it easy for you to troubleshoot. So this is a graphical chart. So the function chart is basically just a flow chart, right? You understand that? I can't get rid of my hand. Does that have gender? I guess they do. I don't know. So I don't know everything, guys, so even though some people think I do. So this is a step chart. And you can see how it's got the name because it shows the steps. So we do the same thing, but our steps are horizontal instead of vertical. So we figure out how many steps we have. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. And then, of course, when we get here, what does it do? It goes that way. Notice here it's got 1B1, here it's got 2P1, and they're in the same state to get it back over here to step 1. That make sense? This area. So first of all, we figure out how many. Yeah, so what happens, it says, okay, this is going to bring it back into the. Oh, yeah, it does on mine too, by the way. Yeah, so this would actually be, it'd be 11, but what you got to understand, 11 is actually what? 1. Yeah. So notice all the sensors are in the same position. So 1B1 is off. 1B1 is off or false. 2P1 is false. It's false here. 3B1 is false. It's false here. So the last step, which they're calling 11, is actually taking us back to step 1. So that's a good point. Everybody okay? Then what we do, I'll figure out what I just did. Then what we do is we space it out, and we put what's required to cause it to move between steps. I'm listening. I'm just now starting. Well, I just started. Let me. Okay. Yeah. So you're right. I just started. So let me explain it, and then we'll see if you don't understand. So what we do is we put all the sensors inside the system. So notice it's got 1B1, 1B2. Y'all understand that, right? Okay. 2P1, we know this all belongs to circuit 1. B is sensors, C is a pressure sensor, B is just all the other sensors, and then of course A is actuators. So this whole block here belongs to 1A. Good. So this belongs to what's going on with actuator 1A. All these belong to what's going on with actuator 2A. This is what's going on with actuator 3A, and this is what's going on with 4A. Everybody okay so far? So they get a whole line. Then what we do is we see what's required. So this is when the actuator's in motion. So when it's over here, and let me get my marker, let me do a different color than red. So this is when the actuator's in motion. So here it says it's actually extending between step 1 and step 2.
So it's extending, not extended yet.
Well, that means it's so it's extended when it hits B2. It's retracted when it hits 1B1. So this is when it's in motion.
If I get this right, it's going to say extended for 2 to 3 and 3 to 4, and then it's going to retract on 4 to 5.
Right. During 4 to 5. So yeah, you're right. So between 2 and 3, we're going to expect it to still be extended. Between 3 and 4, we're going to expect it to be extended, and then it should change state. Between 4 and 5, it's actually in motion.
So 1B2 then is sensor.
So this says 1B1 says I'm retracted. Yeah. So that means that 1B1 has got to be true before we do anything. Then when it hits 1B2, we know it's what? Fully extended. And then it stays fully extended for 2 steps. Then we look at this. Notice we got this arrow coming down here. So this say, okay, this sensor right here, 2P1, when it turns on, pointing up here, then what's going to happen to cylinder 1A? It's going to do what? It's going to track. So what we got to do, guys, is we got to follow these lines, these crazy lines, to figure out what else does this sensor affect besides the line that it's on. So we're saying 1B2, it also affects what? It causes something else to happen. What does it cause? It causes, so 1B2 and 3B1, right? When they're both true, it's going to cause this guy to do what? 16. Which is going to trigger 3B2. What's 3B2 going to cause to happen? it's gonna cause our vacuum to do what? Turn on. Yeah. So here, this is what actually happens over here on the left. Yeah. Okay.
You're gonna have to make where you start doing that.
Yeah. Our second lab. First lab we'll do is, the first lab we're gonna do is we're gonna do the function chart. Now, the function chart only shows one sensor, and we're not worried about the other sensors. It shows one sensor, the main sensor that causes it to move to the next step. This guy here basically shows us everything.
So are we doing this on a piece of paper, or are we doing this on the
We're doing it on the board. Yeah. And it'd be hard to do on a piece of paper because every station has. And it would be nice. I'll try to see if I can find some multicolor markers. It would be good to be able to do what? Do them in different colors, like this red. That and is driving me. So when 1D1 goes true because of this guy right here, so it goes true, then what's that going to cause to happen? We follow the line down, and it's going to cause cylinder 3A to retract. As soon as 3D1 goes true, it's going to cause the traverse cylinder to extend. As soon as 4B2 goes true, it's going to cause cylinder 3A to extend. As soon as 3B2 goes true, it's going to cause 1A to retract. And of course, what's nice here, it actually shows you that we should expect what? We should expect this thing to be extended through 3 steps. And we don't have that information on the function chart, right? As soon as the pressure turns off, which is 2B1, and of course to see what's going on, you gotta look back over here, right? 2P1 turns off, it's gonna cause 3A to retract. When 3A retracts, 3B1 is going to go true, and it's going to cause the traverse cylinder A to retract. And then what? So this guy right here does what? Yeah, but it stays off the whole time until we get to step 11, then we're sitting right here again. That makes sense? So this is basically the function chart, but this is a more visible indication of what's going on. So we actually can expect for this to happen. And this is another chart. Which one do you like better? Well, see, that's what we're talking about. So some people prefer the what? The function chart diagram, and some people prefer this. To me, I kind of like both of them. So we're going to develop both of these, and both of them are available in the manuals y'all finally get you'll finally get when we get. I got to check and make sure we got the pictures that show for all the sections we're doing. That end is going to drive me crazy. I should say crazier, right? It's going to drive me crazy. First of all, we need to understand the actuator. Okay. So what we'll do is we'll lay it's just like the diagram, right? We'll lay out the actuators. So the actuator will be the top, normally is the top one. And then, so one, and if you looked at, so basically, the diagram are drawn from the circuit. So this is a typical diagram of one of the modules. And so if you notice, it's set up in 4 different circuits. So there's one circuit. Here's this circuit. And here's this. And notice this is called 1A. So everything that belongs the 1A starts with a 1. So notice this sensor. This is the retract sensor, 1D1, 1D1, 1D2, 1D1, 1D3, I'm sorry, 1D3, and then 1D1. And you can see what they're doing. They start going up, and the closer you get to the manifold, then you start off by numbering what? 1. So that's the first solenoid. So it's 1M1. M is what we use to abbreviate a solenoid. This is what actuator it controls. It controls actuator number 1, and it's the first solenoid in the diagram. 1D1. So 1 is part of the control circuit for actuator 1, 1A. It's the first valve, so it's 1D1. This is the second valve. They go from left to right. It's 1D2. So it's still controlling solenoid number 1. So you know right off the bat when you look at these numbers, you know what actuator they belong to. That makes sense? So this is the Ventura vacuum sensor, which they're calling an actuator. In real life, it's not really an actuator, but that's just the way the circuit. So a true actuator is something that takes pressure and converts it into motion. I guess it gripping, but here's the suction cup right here. So they're calling it actuator 2A. So everything that belongs to this actuator, the control of this actuator starts with a 2. And then they start numbering them from the bottom up, left to right, bottom up. So here's the first solenoid, 2M1. This would be 2M2, 2V2, because this is a valve, I didn't see that. So this is the actual directional control valve, it's 2V1. This would be 2V2. This you can't see, but it's the designator that we're using for so Z means it's some type of gauge. So that's the pressure gauge. Yeah. 2V1, this is the pressure control valve that we use to control the vacuum. So this guy uses a vacuum. This guy uses pressure to develop a vacuum, right? We talked about how it does that through that material. This is the pressure gauge that you see pop up. This is the pressure sensor. It's adjustable, so we have the ability to adjust when it senses the vacuum. So if I turned it too low, the vacuum cup wouldn't pick it up. If I turned it too high, it might just sit there all the time, right? And this right here is the analog sensor. Some of y'all missed out on the test. So this has an analog output. And so the PLCs that we use is the PLC 314C has analog inputs on it. It's got quite a few, in fact, but it's not in the PLC program, so it's not monitoring that sensor. But we could actually, if we had an HMI panel, we do have an HMI panel, but it's not programmed. So we could actually display the vacuum off that thing. We okay? But see how it works? So this is what's really neat. If they draw them correctly, you can go back there. If you had a picture, especially on the Festo lines, because they've labeled every sensor, odds are you're not going to see that in real life. But you're going to be able to have wire numbers. You're going to be working with a module, right? You understand? And of course, you're going to see what type it is. So odds are, and you're also a lot of times they'll put labels out by the sensor. But how long do you think that lasts? The first time somebody replaces it. Odds are they're not going to do what? They're not going to relabel it. So, and we have problems. This is what I want to show you a little bit. Lee, he's got some, so he sent me an email. Let me find my email. Yeah. Well, that's Lehigh real world. So there are some people, that, where they put a term on it, and we had to do that, you know. So yeah, we really, because we understood troubleshooting, and we knew the more messy it was, the harder it was to do that. And we had some real good foremen out there too. So this is the circuit. This is the pneumatic circuit, not the electrical circuit. This is the pneumatic circuit that shows you the cylinders and everything. And this is the step chart that goes with that circuit. I'm going to make sure it is. So like I said, and this is why having multiple ways that you can troubleshoot makes it easier for different individuals to troubleshoot. But we have both of them. And yours may be right, yours may be wrong. This is not being right, this is not being wrong. This is making the attempt right to do it right. And you notice that's basically what this class is about. We had to do this, by the way, this is one of the things we had to do when we did our Siemens certification. So, we had to do exactly what they're doing here. And it gives you a better feel when you actually look at the charts. If you try to make them, it gives you a better feel when you do look at the charts. And like I said, if you have an opportunity, you go working for a company, then that's something you can either do the charts, or you can just learn the sequence of events that happen, and know what's required to cause it to move between them, right? And then you can, so let's see what we got. Yeah, that's what you're going to have to do when you explain it. That's a good question, you know. Is it going to look exactly like this? Probably not, but it should look something similar to this, right? So first of all, you're going to have to do the steps. So if it's got 10 steps, then you'll have 11 keys, right? No, we'll have 10 keys because we start with one on this one. So you have the same number of keys, and do the best you can on drawing them and making them spaced out. And then you'll come over here on the left-hand side and just put the actuator.
The more I look at it, simpler.
Huh?
The more I look at it, simpler.
Well, it's simpler it gets. And like I said, this is visual. The function chart is not visual. It doesn't show you that we could figure it out, but it doesn't show you that 1A is going to be extended for 2 steps. And right here, we know it is. So the function chart does this, moves this, moves this. And you say, well, but cylinder 1A is back up here, right? Two steps away in a function chart. It's still two steps away, but here we got a visual look that we know this guy should be what? It should be extended for 2 steps. That information is in the function chart, but you would have to actually go back to this step up here, right? Say, well, has it retracted yet? Is this thing retracted? So this is a visual representation of that function chart. So this is actually showing us how long. So I know this guy right here is what? I know it's going to be I should expect that vacuum to be on for 1, 2, 3, 4 steps. So you can press that button 4 times, and the vacuum would be what? It'll still be on. I know this guy right here this traverse cylinder is going to start off retracted, right? For 1, 2, 3, 4, 5 steps. And then it's going to do what? Then it's going to extend. And we know what's required. We know this guy right here is going to set 3B1, but 3B1 is what actually causes that guy to retract. So we get right here. We hit right here and the thing stops. What would be the problem? 3B1. Oh, 3B1, right? You see that? So all you'd have to do is just say, okay, it stops right here. So it stops right here. What's the problem? 2P1. See? Right. So it's just like the function chart. It still gives us that, well, what's needed to make it move to the next step. But this is just more graphical to show you what occurs between steps. Remember, sensors don't come into play when it's doing this. This is when those actuators are what? That's when they're in motion. That's when they're going from this state to that state. So how long is that? Well, I don't know how long. It might be 2 milliseconds. It might be 2 seconds. It don't give us the time for each step. It just shows us what. So notice there what? All the steps are the same size. But, so it's basically the function chart, but it's graphical now, right? You understand that? It's more graphical. So which one do you refer? Like I said, it doesn't make, I kind of lean toward the other one because I've come up through computer programming and I used to have to do flow charts, and that's a lot like a flow chart. But I can see right here how this would be more for people who more visual in nature instead of, logical in nature instead of visual in nature. To try to figure out what's causing this line to stop. And that's the name of the game, guys, is when you're dealing with these automated systems, is getting out there and doing what? Getting it fixed at the smallest time possible. That's when you get paid the big bucks. Hopefully you get paid the big bucks. First, when I was in the Navy, I didn't get paid the big bucks, but I learned a lot. Got to fly a lot. Got to see a lot of countries, guys. A lot of countries. In the West, in the Pacific. Oh, there's my hand. So y'all got any questions on this? Any more? Huh? Yeah, well, it's actually 10. It's just that we put the 11. We put the 11 block out there. That's the one, right? So we still only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we still have 10 blocks, right? That makes sense. So that's a good question. Any more? So I'll provide a picture. I'll provide the picture that shows you all the sensors. It gives you the names of